Okay, let's take a look at some related rates. I'm going to work a couple few problems with you, the main types that we can see. The conical tank is one of them, and you're going to see a question like this most likely in the AP test as well. But before we begin, let's take a look at what we need to have when we look at related rates. Well, the first thing you're going to need is what is it you're trying to find. The second thing you're going to need is, well, what did they give you? Kind of like in your physics class. And then the third thing, now this is not always, this is kind of like a splat, but you're going to need some sort of picture, a graph, something to help you take a look at it, to understand what's happening with the graph. And the fourth thing, and this is the most important part, you're going to need a mathematical relationship that can describe the situation. And in most cases, it's going to be a geometric formula. Pythagorean Theorem, volume of a cone, volume of a sphere, anything like that. You need all four of those to begin solving these, okay? So let's take a look at the first example. Water is running out of a conical tank at a rate of 2 cubic feet per minute. So this is kind of like what they're giving me. So I'm going to write that down. They're giving me the change in volume, dV dt. It's running out, so it's going to be negative 2 cubic feet per minute. The radius of the top of the tank is 5 feet. So again, that's another given. Radius is 5 and the height is 10. And now they ask me this question. How fast is the water level sinking? Now we're going to talk about sinking in just a moment. That's a big word for us. When the water is 4 feet deep. Now, when we're talking about sinking, we're looking for the change in height. So I'm going to write that down. What is it I'm trying to find? My change in height. Now, because it's sinking, it's going to give us it's going to be a little bit more difficult. Now, but they give us the height of the water at the time. Now be careful, this is not the height of the water. These are just for the tank itself. When I'm looking for the height of the water, it's going to be normally 4 feet. But because it's sinking, we measure top down. Well, the top is at 10, so I subtract the 4, so my height is going to be 6. So I take a look. I have what I'm trying to find. I got my given. Now the next thing I need is a picture to explain all of this. And it's a conical tank, so I draw it. There's my conical tank. Like so. It has a radius of 5 and a height of 10. So what we can do with this is find out its volume. Well, we know the volume, and now in the fourth step. The volume formula for a conical tank is 1/3 pi r squared h. Now I'm asked to find dV dt, so I have to take the derivative. But there's a little trick here. I don't want to do product rule, so I'm going to replace either r or h. So I look at what I'm trying to find. I'm trying to find the change in height, so I want everything in terms of h. So I want to replace this r right here. And I can do that by using right triangle trigonometry. R over h is the same as 5 over 10. In other words, r is 1/2 h. And I can use that to plug it in. So my new volume equation becomes this. 1/3 pi 1/2 h squared times h. And that gives me my new volume equation. 1/3 pi times 1/4 h cubed, or 1/12 pi h cubed. And there's my new volume formula. Sorry. Now, we haven't taken the derivative yet, but we have everything for it. Now, I'm going to take the derivative. Because I'm looking for dh dt, I take my derivative. So, taking the derivative, we get dv dt equals, be careful, when you drop your power, that becomes 1/4 pi h squared dh dt. Now notice, I'm not going to use a calculator here. Calculators kind of slow me down. I am worn out. I don't need calculators. I get negative 2, that's my change in volume. It's negative because it's going down, equals 1/4 pi, my h, remember our h is 6, not the 4, because it's sinking. So I'm going to put that in here. The 4 squared, and dh dt is what I wanted to find. Therefore, with a little bit of algebra, I can now find my change in height. I'm going to multiply both sides by 4. That gives me negative 8. And I'm going to divide by pi in 16, so 16 pi. And now I want the units. The height is being measured in feet, so that feet per minute right here. So we can say this. The height is So we will say that the height is decreasing because it's negative at 8 over 16 pi feet per minute. And you can put that in a calculator if you want to, but this is just as well. So let's take a look at one more on this one, and then we'll take a look at one of the harder ones, the shadow problem. So, alright. Here we have Bilbo. Bilbo is on top of a 30-foot ladder. And the bottom is resting 18 feet from a wall. Frodo, in one of his playful moods, starts to pull the bottom of the ladder at a steady rate of 0.5 feet per second. The question that we're asked here is how fast is Bilbo falling when the ladder is 14 feet from the wall? Not the floor, the wall. Sorry about that. Typo. So if I draw out the picture, well, first of all, let's take a look at what I'm given. We know that the ladder is being moved at 0.5 feet per second. So in a case like this, it might be easier to draw a picture first. It's going to be a right triangle. Right triangle. We have A, we have B, we have C. And here's what we're given. We know C is 30 because that's how long the ladder is. We're going to assume that that's the ladder because here's Bilbo on top of the ladder and here's Frodo pulling. We know that Frodo is pulling the ladder at a steady rate of 0.5 feet per second. And that's giving me dB dt. So that's giving me the change in B. dB dt equals 0.5. And it's point positive because we're moving away from the wall per second. Now they give me other things. How fast is Bilbo falling when the top of the ladder is 14 feet from the wall? So that's also giving me B. So we know B is 14. Like so. Now, it also asks me what I'm trying to find. Tells me what I'm trying to find. How fast is Bilbo falling? That's the rate of change of A. dA dt. I need to come up now with an equation that explains all of it. Take a look. Graph, given, find, now my equation. And of course, this is an easy one. Pythagorean, a squared plus b squared equals c squared. And I take the derivative. So I get now 2a dA dt plus 2b, or not to b, dB dt equals 2c dC dt. And I have everything except for a. I don't have a. So to get a, that's just the Pythagorean theorem. So to get a, I might use my calculator here. It's going to be 30 squared minus 14 squared. And it gives me the square root of 704. Wow. Okay, so if I simplify that, I'll use my calculator on this one. I get 26.5. So about 26.5 feet. Right there. So when I start working now if you notice, did that 18 feet really have anything to do with the problem? No, because he's moving it this way. Now, if I start plugging it in, I will. Now if you notice they all have 2's, they all just cancel. We know A is 26.5. dA dt is what I'm trying to find. Plus B, which we know is 14. Okay? And we know dB dt, that's our 0.5. Equals C, which is 30. Now, we don't know what dC dt is, but we can kind of think about it. It's the ladder. So we need dC dt. And it's going to be 0. The ladder's not changing its length any. Remember, this dC dt is how fast the ladder is changing. And the ladder's not changing, so that's going to be constant. That's 0. So I can get dA dt equals, if I bring this over, I get negative 7 over 26.5. And I can use my calculator for this one. I get negative 7 divided by 26.5. And I get negative 0.264. And again, that's going to be feet per second. So, and it should be negative. Think about it. 99% of mathematics just making sense of your answer. He's going down. You're going down, Bilbo. So it should be negative. Now we're going to finish up the rate of change of the angle, and I have another one on the other video. So make sure you take a look at that one, okay?